Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about electric vehicle fires. So let's dive deep into it. So let's just simplify some scientific facts here, is that any vessel or any technology or any stuff that is an energy carrier, by laws of physics itself, always has the ability to dump that energy rather than giving it out controllably. Meaning, when you see a car fire like this, it's the same thing that happens inside a combustion chamber. It's just that there is control, here is dumped. You do not want to be dumped. That's the one thing you have to understand fundamentally. And it does not make a difference which carrier it is, be it hydrogen, be it ammonia, be it petrol, diesel, battery, coal, whatever the heck have you. This will also happen. So you have to understand anything that can have energy and carry it from A to B always has the extra potential to give you some extra love. And that's the primary reason why whenever we are making nuclear fuels for reactor, it's not enriched to the same level as boom boom device, because it will actually go boom. We have to make sure that it's not boom pot, like fundamentally laws of physics, it cannot go boom. So that's the one thing you have to understand. So if you have an electric vehicle that has electricity, fundamentally it has the technology to dump that electricity uncontrollably. So that's all there is to it, and that's what we call burning, in short. So that's the source of fire. If you have energy source, it does not matter whether it's a fuel, or many times people have a hard time understanding. It's like, why the heck battery catches on fire? It has energy. Even if you had a steam system, it could also carry energy. Like there are locomotives that are designed to be fireless and they are using pressurized steam carrier that can also sometimes go kaboom. So this is one of the things that you have to understand. So let's understand the core physics level. Fuel versus battery. Now, fuel has a lot of energy, and I'm reasonably sure nobody needs to be made, clear about that. That's like known law of physics. Now, question becomes why? Why exactly does fuel have so much energy? Well, the reality is it's only carrying half of the equation, meaning it has half part, and then it gets married to, basically oxygen in the atmosphere. Then they get divorced, and that divorce is the energy that we run on. So it only carries half of it. On top of that, there is an inherent safety barrier. That safety barrier is that our atmospheric oxygen that you and I are breathing and our car breathes on, it's only 21%, meaning there is enough nitrogen to contain any runaway reaction. So that's a really good safety function for our atmosphere. So whenever you have like LPG cylinders that we use, propane tanks for you, basically if you can have a wet cloth and you can just make a roll out of it, and it's just like, chill bro, chill. Why? It's half of the equation. So you can take care of basically fuel fire. It does not matter whether it's gaseous fuel, does not matter whether it's a crude oil. Of course, some would be difficult, some could be harder, but we had 1 century of experience, so we know how to deal with this. You can deal with this. This is a common public demonstration that is done to educate people on how to handle it. And that's why, like, whenever you see people stomping on fire, it works. Why? Because you are cutting off the other part. So that's how it has the energy. That's why it has so much of it, and it's so controllable, because it's only half and the other half is concentrated, diluted. And if you concentrate this other half, you get a rocket engine. Fun fact, RDX has less energy than petrol or diesel. It just has the ability to dump all of it in microsecond. So that's the part of it. And batteries, battery has a more closer relationship to TNT than basically fuel, simply because battery has both part. If you look into any battery chemistry, does not matter which it is, even lead acid, they have stuff that is going from phase A to phase B, and then vice versa when you are charging it. That's all there is to about it. Basically, anode, cathode, things moving back and forth. That reaction is contained inside a container. That container. And that's the fundamental problem with battery fires, is that battery itself has everything that it needs to go boom boom. And that's the fundamental reason why it can never ever have the energy capacity of a fuel. I mean, like, there are some people who are saying that you can use some nanotechnology and carbon nanotube and graphene. If, let's just say that can be done, I do not want to be near that battery. No, sir. Because a battery that, let's say, has this sort of energy and has everything that is inside it, to carry energy, yeah, that's a big ass boom. I do not want to be near that. So that's the fundamental difference between fuel and battery. Fuel, that's why we can manage it, because there is always only 21% oxygen that is there. If you can cut off the oxygen supply, you can take care of it. That's why putting out fuel fire, it's a known technology. We know this. We inherently even understand it. Battery, we can't do anything about it. So even if you are extinguishing, quote unquote, battery fire, it's not doing anything. You're just doing something to it. It will catch back on fire. So this is why battery fires are so difficult. It has both components inside, meaning you can heat it into the space vacuum, it will still burn. You can heat it inside a ocean, it will still burn. So let's understand the first-hand experience of firefighters. Now, all firefighters in all countries, be it Australia, be it America, be it European Union, be it India, they describe electric vehicle fires, especially in China, as nightmare. TLDR is just that. It's a nightmare to deal with. Now, the primary reason for that is water is not actually doing anything. Like whenever you are doing water to a fuel fire, you are doing multiple things. First, you are sequestering the fire, basically reducing the temperature so fuel does not ignite. Okay, that's one thing. That's good. Then again, you can also have foam into it so it does not spread around, and that also creates a curtain that is, removing the oxygen and making sure that fuel no longer has fresh oxygen to keep burning. That's awesome. It does something awesome. In battery, it does not do anything. Whenever you are talking about a Tesla catching on fire or whatever have you, it's firefighters are not doing there anything. All they are doing is making sure other things don't go boom boom. And if you're talking about, let's say, electric car that just caught on fire and firefighters are going all in, all they are trying to do is make sure other cells don't go in what we call thermal runaway. So once cell goes boom boom, it has dumps enough energy, more than enough energy, that cells surrounding it can start to run away. Once they run away, the whole pack will run away. Once whole pack will run away, generally a car like Tesla will have multiple packs. One pack runs away, 99% chances that all the car is going to be going poof very quickly. So all you are doing, dumping water there is to contain the temperature. And because it has all of the things it needs to carry out that reaction is fundamentally brutal in terms of temperature. How hot the temperature is, that's the reason why it takes so much water. Because if they let it burn, if they're like, okay, we can't put it out, let's just let it be, yeah, it's gonna melt through roads. Not joking, there are people who experimented with like Tesla battery packs and it started to catch on fire. Battery cells, I'm talking single cell, not the battery box, just the cell, it literally fell into tarmac, like a road surface. It sank in to some extent. A single cell had that much energy that it sank in tarmac. That's why it needs this is a very good comparison. I have linked the video down below where you need 1400 liters of water to take care of a one car fire. Be mindful, we have enough car fires that this data is absolute. In terms of electric vehicle, minimum is 30,000 liter. And the problem with that is one single fire truck is not enough. So that temperature that is there, it's brutal. If you are not continuously cooling it with water, it will melt through everything. That's the scary part of it. On top of that, it also has fumes. For example, in a basically combustion car, we had enough fire. So we had enough time to develop everything that goes around the car. For example, the plastics that are used, the materials, all of that. And if your company did due diligence, if they're not complete, I'm going to poof people for profit, there is a very good chance everything in your car, even if it burns, it's not too dangerous. But when you're talking about electric vehicles, the cobalt in there, yeah. Again, as of now, firefighters are genuinely scared of the toxins that are coming out, and especially in Australia, they are trying to introduce new filters that will take care of the lungs part of the firefighter. Yeah, so not only the temperature is bunker high, the fumes are also idiotically toxic. So that's bad. On top of that, it also restarts. It will not turn off unless every single cell burns. So let's say a car is there, awesome, it catches on fire, firefighter was just next to it, they start to dousing it instantaneously, everything is awesome, people get out, nobody gets hurt, awesome. You're gonna tow the car, here's the deal. While you're towing it, it will catch on fire again. It has happened. And then while you are dumping it into a junkyard, it will catch on fire again. And yes, that has also happened. So that's the worst aspect of it. And when it happens, when it catches on fire, and do not mean reigniting or something like that, just the first time it starts, car is a write-off. You cannot save the car. Car is done, gone. That car is done, fundamentally done. Unless you have a technology where you can just yeet the battery box out of it, which again, I have not seen any car design that has that logic built into it. Yeah, the whole car gone. It restarts on, and there is no true way of putting it out. This is another aspect. Like this is second time this is happening where apparently electric cars catch on fire and they complicated the issue. Now here's the deal. Why the heck they have issue? They have so much water. Again, people who deal with marine, they know, I do not know. I did not knew before this, is that if you dump so much water inside, you will unbalance the ship basically. That could cause an issue, and worst case scenario, you are flooding the ship, it will sink. So the only way they can take care of it, if they detected the fire very quickly, it's like it starts to catch on fire, they've detected the fire and they just yeet the battery, basically yeet the car into the sea. That's the only thing they could have done, which again, given the fact this is a transport system designed to make sure that vehicles are safe, so I don't think they have a yeet mechanism for electric vehicle, which I think that's the only thing you can do in this sort of situation where it's like, oh, you're transporting electric cars. Yeah, they're going to be carried into special operations where if it starts to smoke, yeet. I'm not going to risk my multi-million-dollar vessel for your $100,000 car. Your car goes yeet. So that's the whole thing. And this is another example. This happened in China where you can see like they're putting it out. While you're putting it out, it goes kaboom. And be mindful, we know these sort of things, but a fuel fire, even in diesel car or LPG or CNG, none of them goes as brutal as electric system. It's bonkers how hard it is. And again, some companies are experimenting on creating a spike that you put inside a car, burning car, and then just yeet spike through the battery compartment and flood it internally. I'm not sure whether that's a good idea, or B, that can it be even done simply because every car manufacturer is putting armor reinforcement below the deck to make sure the battery does not get punctured. So again, I do not know who will win. Again, it's a matter of energy. You dump enough energy, you can punch through it. That's not an issue. It's just like, so that's why firefighters, they are flat out not prepared for the hassle this is. And they are giving flat out warning that thou shall not have multi-story building and battery car there. Because if it catches on fire and you do not detect it early enough, it will compromise the whole structure. That's how hot it is. And once it burns, like you have to only yeet that. And water is just there to like make sure other things around it does not get compromised. So firefighters, they are like, no thanks. So what about chemistry? Now that's the problem. Firefighters don't like it. And again, fundamentally, we cannot do anything about it. Levels of chemistry is like, hey, I have both parts of the equation. I'm going to go boom, boom, but you can't do anything about it. So how can we solve it? So first layer of problem is chemistry itself. Chemistry itself is causing issues. So you have to understand this. Whenever we are talking about lithium ion chemistry, it's an umbrella term. There is multiple chemistry of basically lithium ion itself. So not all chemistries are the same. Some chemistries, they make extra love. Other chemistries are a bit more gentle. For example, lithium titanate battery. Now these things, the blue cells, they are surprisingly robust. They are robust enough that you can have a cell while it's powering something and you can cut it using a chop saw. It will not go kaboom. And this is a video that I have linked down below. You can puncture it, overcharge it, discharge it, do whatever the heck you want to. It will not cause fire. It will burn. Be mindful. If you set it on fire, it will burn like it's burning a wood. But it will not add to fire. It will not be like this. This will not happen. So this is one chemistry. It does have some other benefits also. For example, it has surprise, the amount of C and D it can handle is bonkers, meaning you can charge it inside an hour. Lithium ion is generally rated for 1C, meaning charging in 1 hour. This puppy can easily charge in 2C, that is 30 minutes, or you can go even lower than that. 3C is 15 minutes. Even lower than, by the way, these things are very close to capacitor level. So you can charge them very quickly and discharge super quickly. So they are ludicrously powerful, and temperature range is also very awesome, meaning it can work in Alaska to India. That's awesome. Consequence, capacity is low, meaning if I give you, this is the box, the battery box size limitation, the height, length and width, and this is the weight capacity, how much oomph you can carry, that's fundamentally less. I did specify anything that has the ability to carry energy fundamentally has the ability to dump it. It does not have the fundamental energy to dump that energy, means it also has less energy, not too less. Be mindful, from lithium ion, if you compare this to, let's say, lead acid battery, it's fundamentally more closer to lithium ion than it is to lead acid. Then you have lithium iron phosphate. Now, I'm shocked that early days, lithium manufacturers were kind of wise enough that they were like using lithium iron phosphate for cars. If I'm not mistaken, Mahindra's Evo car that was released in India had lithium iron phosphate cells. Now, like, what about this? Well, this cell has the same thing. It will swell, it will gas out, but it will not add fire to your system. And it is fundamentally same, even if it gets punctured. So on a core level, it's safe. It's same safety as LTO cells. So that's awesome. Unfortunately, it also has the same problem that it does not have the same oomph. And it's not as robust as basically LTO cells. However, it's also cheaper. So if we use this, then why the heck we abandon it? Everybody got range fever. Everybody. Even though practically speaking, most people do not drive more than 40 kilometers per day, the moment you say that there is something known as range, even though people who have 2 cars, they can be like, hey, one car is for like, long range, another car is for my day-to-day from my home to office, which I'm going to do for 30 years. How about that? I'm just taking care of that part, but then no, I need range. It's like, we just got so hung up on the range. Even the manufacturers who knew that this is much better, much safer, fundamentally it's safer, they are like, okay, we have to abandon this and go into lithium polymer cells, which has more power. That's good, but it also goes boom, boom, more powerful. So that's the issue. Now, be mindful. Can we make a very competent car with lithium titanate or lithium iron phosphate? Absolutely. However, range would be fundamentally lower compared to normal lithium cobalt system that we are using. However, more and more, because of a fire causing hazard and the fact that nobody can put it out, that's causing much more psychological trauma to people. So brands are switching back to LFP because they're like, you know what? Range, we can deal with things, but if your car burns so hot that it's going to burn through the concrete, which I genuinely hope, I do not want to read in a news article that someplace there was a car that like nobody can figure it out whether it's burning or not, and nobody can dump water to cool it, burn through it. And I do not want to even think about what will happen if electric truck that has 800 volts of potential and God knows how many kilowatts of energy, as in like 60 kilowatt hour of capacity, if that puppy burns. And we must know it has safety. Yes, in road, safety is not a thing. Why? Because there are two reasons why things go boom. A, you did something boom, boom, it went boom. Another thing is somebody else boomed you. What the hell are you going to do about that part? It's like, my car is awesome, I'm going to drive it perfectly. Yes, what about somebody else that is drunk? So that's the chemistry line of defense. You fundamentally change the chemistry so it becomes fundamentally safer. I really do not like the idea of people are like, I have tested it. What have you tested? You tested something that is fundamentally going, oops, equals boom if voltage is wrong, if temperature is wrong, if overcurrent is drawn, if overamp is dumped. In all scenarios, it goes boom. It's like, how about you put something that is fundamentally safe, then you make it safer. Benefit of that would be super long lifespan. Be mindful. All these technologies, basically the better ones, they generally have much longer lifespan. So not only you're going to get a much safer vehicle, you're going to get much longer lifespan. Consequence would be the range. So if you do not have range anxiety, or you have like two cars and you're like, hey, if it can give me 50 kilometers reliably, I only drive to like, let's say 20 kilometers per day, you will be a good, happy man if you are driving this sort of technology rather than lithium polymers. So what is the solution number 2? That's the solution number 1. Solution number 2 is biofuel. Now I specified fuels are fundamentally, on the laws of physics, they are fundamentally better. You can never make a cell that would be better than fuel, and if you came close to actually making that has that kind of energy. I specified that TNT has more, far fewer basically joules basically compared to diesel. Which boom boom you want to be next to? Obviously fuel one. Again, ideally you will not be next to anyone, but if you have to choose, you will choose few. There is some probability you will survive. The reason was the same. If you have a system, let's say you used carbon nanotubes or graphene to increase surface area exponentially, you're also increasing the ability of going kaboom exponentially. So I would not want to be near a cell that has like 10 times more power than this. And be mindful, all the researchers who did the safety analysis, they figured out you have solid cell, it will do the same thing. But of course, it will not do the same thing if overcharge or discharge. But in an accident, be mindful, road, things happen. In an accident, it will go boom, boom again. So fuel is better, flat out. It does not matter which fuel you're talking about, but fuel is better compared to cells, be it even hydrogen. So what is the best fuel for Earth? Best fuel for Earth is liquid hydrocarbon. Why for Earth? Well, Earth has an atmosphere. That atmosphere carries oxygen. Not too much oxygen, not too little oxygen. So that's awesome. That's the perfect band. On top of that, our room temperature and standard pressure allows many hydrocarbons to be liquid, basically going below ethane. Ethane, I'm saying, where if you have basically like diesel, petrol and all that jazz, those are heavy fuels, very stable in room temperature. And we had 1 century of research and development. Everything in your car is designed to make sure, even the cheapest car is designed in such a way that it will just not magically go kaboom. And cars have caught on fire. They do caught on fire, but it's something that we can manage. And it has pre-built infrastructure, meaning can we build electric car infrastructure? Yes. Can we actually do it when 100% of electric vehicle is running on electricity? Yeah, doing that will fundamentally put strain on the grid so much that we have to upgrade our grid. And again, that's unnecessary. That's like trying to put a round peg through a square hole. You can force it, but it's like, why? So we have research and development to know how the heck fuel works. We have pre-built infrastructure of delivery, transportation, safety, all of those things are sorted, and fire brigades knows how to handle that. So that's there. So what's the problem? Well, problem is the fossil part. We do not want to cook our earth. So what if we take fossil fuel, heat the fossil part, put a bio part there? Can we take care of it? Absolutely. Is there a technology that actually allows us to do biofuel? Yes. We just had to upgrade from generation 1. Generation 1 was Rudolf Diesel when he was using peanut oil, basically. Basically he was using vegetable oil to run the engines. Were they perfect? Absolutely. They worked fine. Everything is awesome. Then why didn't we expand it? Well, we did. Then government banned it. then he disappeared from a boat where he was very happy. So that happened. Like, you can look it up. Like, there was a dude known as Rudolph Diesel, then he magically disappeared. So it's a known thing. And again, be mindful, diesel was not a fuel, that there was no fuel named as diesel. But after his poofing, then fuel was named diesel in his honor, so people were like not suspicious. And be mindful, if you actually grow the fuel on land, all you are doing is running on solar energy. And the hydrocarbon has two parts, hydrogen and carbon. Where is the carbon coming from? Carbon dioxide. It's taking carbon dioxide, yeeting the oxygen out of it, and taking the CO. It's taking water, it's yeeting the oxygen out of it, it's taking hydrogen. Getting these two together married, basically carbon and hydrogen married together. And what is allowing this sort of energy? Sun. So it's a completely continuous cycle. You can keep doing this till infinity without cooking the earth. Now, why didn't we expand that part? Because be mindful, after Rudolf Diesel, Henry Ford came into being, and he wanted to use ethanol, again grown out of fuels, crops, so to say. So why don't we use that? Problem is, our consumption is much higher. If we even touch biofuel on soil, we're gonna poof our soil, because we consume so much that soil cannot sustain it. So we need ludicrously large surface area. We need insanely large amount of energy, solar energy, to do this. So what can we do? Seaweed biofuel. Why? Surface area problem solved. It's not used for basically growing crops, so food prices will not go up, which somehow America was like, thou shall use corn to make fuel. It's like, you're gonna increase your food cost exponentially, and they did. Brazil, we're gonna use sugarcane for fuel. You're gonna increase your food cost exponentially, and they did. That's why we cannot touch land for biofuel. So we have to use basically seaweed. Why? Surface area and solar area, and all the hydrogen and carbon coming infinitely cyclable. You don't have to worry about it. It's carbon neutral. Now, is there a problem with this sort of strategy? Yes, emissions. When you're talking about electric car, they do not have any emission. Now, our emission standards have become exponentially better compared to last 50 years. That's absolutely true. Emission every 10 years is getting lower and lower. Now, will it ever comes to zero? No, physics does not allow that, but it can be made low enough where it's like, not too bad. On top of that, we can also introduce serial battery hybrid system, meaning you have an electric basically motor generator unit that is driven by a engine. That engine is converting fuel to energy, and that energy is going to battery is driving the car. Now, is it like submarine? Absolutely. Now, didn't we do that? No. What we did was parallel hybrid, basically what F1 does, where you have engine and motor working together. Consequence, it's looks good for F1, but the moment people try to put this technology into basically normal commercial car, it catches on fire. Not even joking, the highest fire rate is in basically hybrid cars. Hybrid, petrol, then electric. So you really don't want that sort of system. And be mindful, it's super duper complex. They have clutch systems. Electric car that has clutch system, it's like, why? So you have to go to what we call serial hybrid. Benefit, you will get regen from braking, and because your engine will be decoupled from the driving loads, it can be designed to run at optimum RPM for efficiency. Rather than power, is to optimize for efficiency. You and I get more real world mileage out of it. And be mindful, if you have small battery bank, it's best for both worlds. You can still have a charging infrastructure, but it will be like, hey, if I only drive for, let's say, 10-20 kilometers per day, I'm just using the battery part of it. If I have to go far, put fuel into it. And because it's serial, it will be far more efficient. And be mindful, if we ever developed fuel cell that works on hydrocarbon, heavy hydrocarbons like liquid hydrocarbons, we're good. We just swap the engine part, put a fuel cell, which some companies are claiming that they have developed it. That would be awesome. Emission would be controlled far more effectively. It will give us best of both worlds. And it will not have the issue of like, how the heck you do trucks. We have everything sorted. We just have to go this part, which thankfully at least some researchers have brain that they are actually working on it. At least 300 researchers are working on it. So this was my presentation on basically electric vehicle fire. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.